Hello students, welcome to the channel. In today's video, we'll solve the science section of the 2021 April ACT Form D05. So let's begin. Passage 1, solar time is determined by the position of the sun relative to a meridian, an imaginary line that passes through the northernmost and southernmost points of the horizon, dividing the visible sky into two equal halves. At solar noon, the sun appears to cross the meridian. A solar day is the period between one solar noon and the next. Because the sun's apparent motion is not uniform, a solar day is generally not the same length as a mean day, which is exactly 24 hours. Okay, so here you have the first figure, which shows that the length of the solar day can vary, right? It's not exactly 1440 minutes. It can vary, right? Figure 2 shows how the difference between solar time and mean time varies throughout the year. So for example, if the difference between solar time and mean time is positive, solar time is ahead of mean time. And if the difference is negative, solar time is behind mean time. And this is in minutes. Okay. Based on figure 2, on how many dates each year is solar time exactly 8 minutes behind mean time, right? So we're looking at 8 minutes. So that's, let's say this is 8 minutes, right? This line. Actually, I'll just draw with hand. Give me a second. Yeah. So solar time is behind. So we are looking at -8, something like this, right? Around here. So there are 2 days, right? There are 2 days that it happens between, in 1 year, right? Where you have a -8, which means solar time is 8 minutes behind me. Yeah, so it's A. Okay. According to figure 2, on which of the following dates does solar time have the same value as the mean time? Okay, so that means it could be this point. It could be this point. It could be this point, or it could be this point, right? Where the difference between the two is 0. So that could be between April and May. So April 15 seems like a good answer, right? Because April 15 is right in the middle, this point, right? So I'll go with April 15. Yeah, okay. During the first 6 months of the year, is solar time more often ahead of mean time or behind mean time? So during the first 6 months, you see that the graph is mostly negative. So solar time is mostly behind mean time, right? Because the difference between the two is negative. So yeah, so it is, solar time is mostly behind. The difference between solar and mean time is more often negative during the first 6 months. So it's D. Okay, according to figure 1, on which of the following dates is the solar day longer than the mean day? Okay, solar day longer. So we need to be more than 1440. So we need to look here. So it could be anywhere in this range or this range or this range, right? We need to basically look at the graph above the 1440 axis. So what are my options here? February 15, February, March, June, and August. So February 15, I don't think so. No. March, no. June, yeah, June 15 seems fine. Yeah, June 15 seems fine. So June 15. Okay, according to figure 2, in a given year, solar time is ahead of mean time for approximately how many months in total? So we basically looking at solar time is ahead. So we are looking at the parts above. So this is about 2 months, right? Because you have a 0.5 and a 0.5 here. So it's about 2 months, and this is about 1, 2, 3, 4 4 and 2, 6 months, right? A little about 6 months. 4, no, it'll be 5.5, I think, because we have to leave out this part. So around 5.5, I would say. Yeah, 5.5. Okay. Based on figure 1, the longest solar day of the year is approximately how much longer than the shortest solar day of the year? Okay, longest solar day is here, I think. Yeah. This is the longest solar day. Yeah, it seems to be the same as when it started, right? So we'll take it as around 1440.42. So let's say actually this I'll write, yeah. 1440.42. And the lowest is here, which is 1439.62, right? So 1439.62. Okay, this is 62. Okay, never mind. That's the problem with PDF sometimes. I'll just write it as this. Yeah. Okay, so that's 0.8, right? Yeah, so the difference is 0.8 minutes. Yeah, so that's G. Okay, let's go to the second passage. An experiment was conducted to determine how seawater temperature and salinity affect food consumption and growth in Scophtalmus maximus, a species of fish. The table shows for each of 8 trials average total food consumption, CT, and the average gain in body mass for S maximus, kept at various temperatures and salinity combinations. Each trial involved the same number of fish and lasted the same number of months. Okay. Based on the table, for which 2 trials was the average CT value less than 50 grams and the average gain in body mass greater than 75? Okay, so CT value. Okay, so I'm just going to use this. Let's first find less than 50, right? So this is less than 50. This is this, and this, right? So there are these 1, 2, 3, 4, 5 values and trials 3 to 7, where I have a CT value of less than 50. And then I have to check the gain in body mass greater than 75. So that is true for this and for this, right? So these are the 2 values out of those where I have, so it's trial 3 and trial 7, right? So that's option D. Okay, consider trials 1 to 4 based on the table. As salinity increased, did average CT increase or decrease? And did average gain in body mass increase or decrease? So if you look at salinity, this is how the salinity is increasing, right? So it's increasing 15, 20, actually not the whole way. Salinity is only increasing here till this point, right? So you can see that CT is decreasing and average gain in body mass is also decreasing. So they are both decreasing, CT and average gain in body mass. So that's H. Okay. Consider the 4 trials for which the average CT values were less than 45 grams. Okay. So let me just clear all of this because now we are looking at average CT value of less than 45 grams. Okay, so that was 1, 2, 3, and 4, these 4 trials. So what's the question then? What is the order of these trials from the trial with the least average CT value to the trial with the greatest? So least is trial 5. So I'll cancel C and D. Then the next is trial 6. And the next is trial 4 and then trial 7, right? So 5, 6, 4, and 7, option A. Okay. Based on the table, average gain in body mass was approximately how many times as great for the S maximus in trial 6, average gain in body mass. So I'm looking at this, was how many times as great as this as it was in trial 5. So that's approximately 2, right? Because 50 is twice of 25. So I'll take it as 2. So that's, wait, yeah. Suppose trial 1 lasted 3 months. How many months did trial 8 last? So that's 3 months, because it's given very clearly here that they lasted the same number of months. So it would have to be 3 months, yeah. Okay, what was the average CT in kilograms for fish kept at a temperature of 22 and a salinity of 25? Kilograms, okay. So temperature of 22 and salinity of 25. So that's 52.1 grams, right? 52.1 grams. So that's, if you put 52.1 divided by 1000. So that would make 0.0052, right? Yeah, wait, it is 52.1 grams. 1 second. Yeah, so then I should divide it by 1000 to get kilograms. So then shouldn't it be 0.00, no, sorry, 0.052, my bad. Yeah, 0.052 kilograms, yeah. Okay, so that's F. Passage 3, 3 studies examine the effects of compost on 3 physical properties of soil. Okay, so 5 soil mixtures were prepared. Percentage by volume. Okay, so first one had 5% compost and 95% soil and so on. Now, a 1.5 liter pot was prepared by placing 500 grams of mixture 1 into the pot, after which the pot was stored at 30 degrees centigrade for 72 hours. The pot and its contents were then baked in a 105 degrees centigrade oven for 24 hours. After cooling, the mixture's bulk density, the dry mass of the mixture per unit volume, was determined. These procedures were repeated for each of the mixtures. Okay. Another 1.5 liter pot of mixture 1 was prepared, stored and baked at in study 1. The dried mixture was ground into powder and passed through a screen with 2 millimeter diameter openings. 5 grams of the screened powder were then mixed with 5 milliliters of water, and the pH of the powder H2O suspension was determined. These procedures were repeated. And another 1.5 liter mixture was prepared, stored and baked. The dried mixture was then ground and screened as in study 2. 50 grams of the screen powder was mixed with 5 ml of water to form a soil paste, and the paste was placed on a filter. Suction was then applied to the filter, and the extract, the clear colorless liquid that passed through the filter, was collected. The electrical conductivity of the extract was determined, and this was also repeated. Okay. Which of the following is the most likely reason that a given mixture was exposed to a temperature of 105 degrees centigrade in study 1? After which the pot was stored, the pot and its contents were then baked. Okay. To allow the mixture to be passed through a screen, to prevent the mixture from being passed through a screen, to add moisture to the mixture, to remove moisture from the mixture. So obviously you're passing it, you're kind of baking it so that you can find the bulk density. So you want to remove moisture, and so you're heating it to a very high temperature. In study 3, once this suction was applied, the filters most likely allowed the passage of so the suction was applied and the extract was collected. So it allowed the passage of liquid, but not solid. Yeah, liquid, but not the soil. Yeah, that is how you get the extract, right? Based on the results of study 1, if a mixture with 60% by volume of compost had been tested in study 1, the bulk density of the mixture must most likely have been. So, Okay, so when it's 50-50, it's 213, and when it's 75-25, it's 255. So it would be between these numbers, right? If it was 60 compost and 40 soil. So between 213 and 255. Between 213 and 255. Option C. Okay. Study 2 differed from study 1 in which of the following ways? So in study 2 and study 3, not 1, study 2. So the dried mixture was ground into powder and passed through a screen with 2 mm diameter openings. Yeah, so here you are not trying to separate the soil from the liquid, right? Which you're doing here. The powder itself was determined, yeah. A greater mass of the screened powder was mixed with H2O in study 2 than in study 3. Just 1 second. So a greater mass of the screened powder was mixed with water. Wait, a greater mass of the screened storage time and mass. Okay, so let me just look at this. 5 grams of the screen powder and 50 grams. Okay, so there it was 5 and this was 50. So greater mass of the screen powder was mixed with water in study 3. So it's G. Okay. 17, consider the mixture that resulted in the suspension with the lowest pH in study 2. According to the results of study 1, was the bulk density of this mixture greater than, less than, or equal to 150 milligrams? Lowest pH. Okay, so lowest pH is for mixture 1. So for this mixture, the bulk, it was 104. So the bulk density is definitely less than 150, right? Okay. In study 2, was the suspension for mixture 1 acidic or basic? So it is going to be acidic, right? Because if the pH is less than 7, then it's acidic. So it's acidic because the pH was less than 7. Yeah. Consider the statement: the percent by volume of compost in the mixture that had the greatest bulk density was the same as the percent by volume of compost in the mixture that had the extract with the lowest electrical conductivity. Do the results of this studies 1 and 3 support this? Okay. So greatest bulk density is mixture 5, this one. And lowest conductivity is mixture 5. So it's true, right? Yes, 50% by volume of compost. No, mixture 5 was 95%. Yes, 95% by volume of compost resulted in the greatest bulk density and the lowest electrical conductivity. Option B. Okay, passage 4. When a sand-covered drum head vibrates at certain frequencies, the sand collects at nodes, areas of least vibration. Two types of nodes can form on a vibrating drumhead: radial nodes, which look like rings, and linear nodes, which look like straight lines. As sand collects at nodes, patterns called nodal patterns form. Figure 1 shows two nodal patterns that can form on a sand-covered drumhead: NP1, a radial node only, and NP2, a radial node and a linear node. Students performed 2 experiments to study the formation of NP1 and NP2 on various drumheads. The student obtained 5 drumheads, each having a different diameter and each set to a tension of 2000 newtons per meter. They performed a trial with each drumhead using the following procedure. First, they placed the drumhead directly above a speaker emitting sound waves having a frequency of 90 Hertz. Then they gradually increased the frequency until they observed NP1. Finally, they continued to increase the frequency until they observed NP2. Throughout each trial, the amplitude, the loudness of the sound waves was held constant. Table 1 shows the frequency at which the students observed NP1 and NP2. Okay. In the second experiment, the students performed 7 more trials with the 50 centimeter diameter drum head. Okay. In each trial, first the tension was adjusted to a certain value, and then the procedures of the experiment 1 trials were repeated. Figure 2 shows the results for the trial and present a line of best fit for each nodal pattern. Okay. Based on the results of experiment 1, for how many of the diameters tested was the frequency for NP1 less than that for NP2? Okay, so it's true for this, it's true for this, it's true for this, and for this. Right? So for all the 5 trials, you see that the frequency for NP1 is less than the frequency for NP2. So all 5. Okay, which of the following questions about either drumhead diameter or drumhead tension can be answered by the results of experiment 2? So as the tension increased, the frequency at which these patterns was formed was increased. Yeah, so what effect did the diameter of the drumhead have on the frequency? No, so it's not, we're not changing the diameter, right? So A and B are out because here we are changing the tension. What effect did the tension of the drumhead have on the frequency at which the NPs were observed? Yes. What effect did the tension of the drumhead have on the time? No, it's not time. We are observing frequency here, right? As tension is changed. So it's C. Okay. 22, suppose that in experiment 2, a trial had been performed in which NP1 was observed at a frequency of 130 Hertz. Based on figure 2, the tension of the drumhead would most likely have been what? So 130, NP1 at 130 Hertz. Okay, so NP1 at 130 Hertz. So isn't it, do I have to look at the line of best fit? Yeah, so if it is, yeah, that's fine. I think I'll just go with the line of best fit. So that's just here, this one, right? So that point is about 1900, right? So 1900 would be the best answer. Okay. Experiments 1 and 2 differed in which of the following ways? In experiment 1, loudness was held constant and frequency was varied. Yeah, frequency was varied and loudness was held constant, right? Loudness was varied and frequency was held constant. No, we're not varying the loudness here, right? We're repeating the same. So it's not this. Okay, here, yeah, I think it's C because here using 5 different drum heads, right? But here you're using the same 50 centimeter drum head, right? So that's the point of difference. Yeah, it's option C. Yeah. Based on the results of experiment 1, for the 60 centimeter diameter drum head, what was the difference between the frequency at which NP1 was observed and the frequency at which the speaker was initially set during the procedure? Okay, 60 centimeter. So NP1 was observed at 112 and it was initially set at a speaker at a frequency of 90. So that's 22, right? A difference of 22 Hertz. Okay. For a given diameter and tension, the fundamental frequency is the frequency at which NP1 is observed. Suppose that for a 20 centimeter diameter drumhead set at a tension of 2000 newtons per meter, a certain NP is known to form at a frequency that is 2.3 times the fundamental frequency. Based on the results of experiment 1, this NP would most likely form at at approximately what frequency? Okay. For a given diameter and tension, the fundamental frequency is the frequency at which NP1 is observed. Okay, now we have a 20 centimeter diameter. So we're looking at this one, the 20 centimeter diameter drumhead at a tension of 2000. What was the tension? Yeah, it was 2000 newtons per meter, 2.3 times the fundamental frequency. Yeah, so this is the fundamental frequency here is 330, right? Because at which NP1 is. So 2.3 times 330. Okay, so that we can just plug into the calculator. 2.3 times 330. So that's 759, option C. Okay. A student claimed that the greater the drumbeat diameter, the longer the wavelength of sound needed to observe a given NP. Is this claim supported by the results for NP2 from experiment 1? The longer the wavelength of sound. Okay, so we know that frequency and wavelength are inversely proportional, right? Because if you like, let me just draw this. So if I have this thing, the problem with this is that it doesn't let me draw this. Yeah. So wavelength is this distance, right? This distance is the wavelength, right? So as the wavelength increases, the frequency decreases, because obviously frequency is how many times this happens, how many times this wave motion happens. So if you increase the wavelength, the frequency would decrease. So here you're saying that the greater the drumbeat diameter, the lower is the frequency at which NP2 is observed, right? So the greater the wavelength, the longer the wavelength, right? So that is correct. Yes, as the diameter was increased, the frequency decreased. So as the frequency decreased, the wavelength obviously would increase, right? So G. Okay, passage 5. 3 students observed that trait R is present in some people, but not in others. The presence or absence of trait R in a person is determined entirely by alleles of gene R. Gene R has 2 alleles, R, capital R, which is dominant, and small r, which is recessive. A teacher gave the students a pedigree showing the inheritance of trait R in a particular family. Figure 1. Each individual represented in the pedigree was assigned a number shown below the symbol for the individual. Okay, so male and female, right? Okay, like that. Okay, based on the pedigree, each student proposed a hypothesis explaining the pattern of inheritance for trait R in this family. Okay, so student 1 says gene R is located on the X chromosome. Okay, so females who inherit 2 X chromosomes inherit 2 copies of gene R, whereas males who inherit 1 X chromosome inherit only 1 copy of gene R. All females with trait R inherited 2 copies of the small r allele, and all males with trait R inherited 1 copy of the small r allele. Table 1 shows the possible gene R genotypes for females and for males and indicates whether the genotypes result in trait R. So if you look at the key here, male is the square and female is this thing, a circle. So without trait R, it's just blank. With trait R, they are both shown as solid, and this shows mating and this shows offspring. Okay. Now in the female, if it's capital R, then trait R is not present. Wait, why is that? Isn't capital R the dominant one? Because males inherit only 1 X chromosome, their gene R genotype is only 1 copy of gene R. So shouldn't, I don't understand, if capital R is the dominant one, Shouldn't the trait be present when it's capital R? Okay, so the trait is present when it's recessive, when small r is present. Oh, okay. Student 2, gene capital R is not located on the X chromosome or the Y chromosome. All individuals with trait capital R inherited 2 copies of the R allele. Okay, and student 3, gene capital R is not located on the X chromosome or the Y chromosome. All individuals with trait capital R inherited either 1 or 2 copies of the capital R allele. So I'm not comfortable with the hypothesis presented by students 1 and 2 because they are relating the presence of trait R with the presence of the recessive gene, which is not how it should work, right? It should be related to the presence of the dominant allele, right? Capital R, which is dominant, right? So, so I'm interested in student 3's hypothesis. That seems correct. Which student, if any, would be likely to predict that the gene capital R genotype of individual 5 is small r, small r? Okay, individual 5. Okay, so individual 5 is the one who has trait R, and it's a male, right? So for a male, so two copies of the RLL. So it would have to be student 2. Yeah. Okay. Which of the following tables is most consistent with the hypothesis of student 3? Yeah, so if it's capital R, it's present. If it's capital R, small r, it's present. But if it's too small r, it's not present, right? So it would be G, because according to him, the capital R, 1 or 2 copies. So that's exactly how the dominant allele and the recessive allele work, right? So it would be, the trait would be present when capital R is present. Which of the students 2 or 3 imply that trait capital R is a recessive trait? Trait capital R is a recessive trait. I think that's student 2 or student 3. Yeah, so it's student 2. He says that capital R, trait R, is a recessive trait. Student 2, because student 2 predicted that individuals with 2 copies of the recessive allele will have trait R. Wait, is it... it's a recessive trait because you would need to have 2 copies of it to be present, right? If it was just 1 copy of RLL and the other one was capital R, then it would have to be, yeah, so it would, so it's A, right? Student 2 predicted that individuals with 2 copies of the recessive allele of gene capital R will have trait R. So only when both are recessive alleles will this trait appear. So then it's obviously student 2, option A, right? Yeah. So yeah, B is just wrong because it talks about just 1 copy, and that's not what it says. Suppose that individual 20 and individual 21 have a biological child. Based on student 2's hypothesis, what is the probability that the child will have trait capital R? Okay, individual 20 and 21. Okay, so 20 has trait R, which means that, so it's small r and small r, according to the second student. Wait, I'll just write it with my pen. So, right, and 21 is also small r and small r. right? Because the trait R is present when so the biological child will obviously inherit two copies. So the probability that the child will have trait R is 100%. Yeah, because both parents have two copies of the allele. Based on student one's hypothesis, is an individual with the gene capital R genotype RR female or male, and does the individual have trait R? Capital R, capital R. Okay, so capital R is female and does not have the trait R, right? So female and no. So it's B. That's according to student one. Which of the students proposed a pattern of inheritance that would most likely result in trait R being rarer in females than in males? Okay. Rarer in females than in males. Okay. So I think this one did, because 2 out of 3 times it's not present, right? While in the case of males, 50% of the times it's not present. So student 1, definitely, it's rarer in females. Student 2, I think 2 and 3 have no relation to female versus male, because they both say that it's not located on the X or Y chromosome. It's only in the first case where a link to maleness and femaleness is made with the presence of its location on the X chromosomes, right? So student 1 only. Consider individuals 3 and 4 and their offspring. Is this portion of the pedigree more consistent with the hypothesis of student 1 or the hypothesis of student 3? Okay, 3 and 4. So there are these and their pedigree. Okay. So is this consistent with student 1 or student 3? Okay. So both of them had trait R, and then the female, there were one female offspring and 3 male offsprings. The female offspring had trait R, and out of the 3 male offsprings, 2 had trait R, right? Now, on just the look of it, I don't think it's consistent with what the first student said, because it seems that the chances of the male having the trait R were greater so let's say that, let me just try and make the man according to, so the trait R is present, which means it's, I'll use a pen. So for this guy, it's R star. And for this woman, it's R and R, right? According to the first student. Now, their children would, this woman has R, and this, one second, this and this guy have R star, and the white one has capital R, which doesn't make sense, right? Because none of the parents had capital R. So student 1 doesn't make sense. Now, if you look at student 2, student 3, 1 or 2 copies, then if he does have 1 or 2 copies of the capital R, then that gets translated to this child, this offspring, who does not have trait R, right? So it's possible that it was capital R and small r, and it was, this is so crazy. Okay, capital R and small r, and this was capital small r and small r. So it's possible that one of the children, this white male, white box male, was small r and small r, and that's why it did not have trait R as per the student 3, right? So it is student 3, it's not A and B. Student 3, this portion of the pedigree suggests that trait R is a dominant trait, right? And because it's a dominant trait, this child did not have it, right? So, okay. Yeah, we have, I think this would be the last passage then. Yeah. Okay, the hot spicy flavor of chili peppers is directly proportional to the concentration of capsaicinoids, a class of chemical compounds. Scientists studied the effects of fertilizer application and pepper color on the capsaicinoid concentrations of three varieties of chili peppers, V1 to V3. 200 V1 plants that were 82 days old were divided into 4 equal groups, and each group was planted in a different plot L, M, N, or O in a particular field. This procedure was repeated with V2 and V3 plants in separate but adjacent fields. Fertilizers were then applied to the type L plots and the type M plots. Each plot was irrigated equally once every 20 days until harvest. All the peppers in the type L plots and the type N plots were harvested 77 days after planting while the peppers were still green. All the peppers in the type M and type O plots were harvested at 87 days after planting after the peppers had turned red. Table 1 summarizes for each plot type whether fertilizer was applied to the plot and the color of the peppers in the plot at the time of harvest. Immediately after being harvested, all the peppers were dried at 65 degrees centigrade for 24 hours. Then for each field, all the dried peppers grown in a given plot were ground up and combined. The total capsaicinoid concentration in milligrams of capsaicinoids per gram of dry pepper was then determined for the peppers from each plot of each field. Okay. The hottest peppers in the study were most likely those of which variety grown on which plot. So the hotness is directly proportional to the concentration. So the hottest was obviously this one. It's the highest. So it was V2 and L. So this was the V2 peppers grown in plot L because they had the highest total capsaicinoid content. That's F. The spiciness of a pepper is often reported in Scoville heat units, SHU. In general, the higher the total capsaicinoid concentration, the higher the SHU value. Based on the results of the study for V1 in the plots that had fertilizer applied, would the SHU rating likely have been higher for green peppers or for red peppers? Okay, so V1. V1, when the fertilizer was applied. So we are looking at V1 and L and M because for L and M, the fertilizer was applied and it is higher for 78 for L, right? 78 is higher. So it is higher for the green peppers, right? Green, the total capsaicinoid concentration of plot was higher than that of plot M peppers. So we are comparing L and M here, right? Because that's where the fertilizers were applied. So it is green because it was higher for L than for M. So it's A. Okay, consider the statement for a given variety of pepper grown without applied fertilizer, the total capsaicinoid concentration of red peppers is generally higher than that of green peppers. Are the results of the study for V3 consistent with this statement? Without. So now for V3, we are looking at N and O, right? N and O. And here again, we notice that the green is higher than the red, right? Green is higher than the red. So the total, so that's not correct, right? Red is not higher than green. So it's a no answer. No, because the total capacitive concentration of, no, it's not about L and M now. It's about plot N was higher than plot O. Plot N was higher than plot O. So it's a no answer. And it's G. Because it is the green one which is higher than the red one. Assume that 50 grams of fertilizer was applied to each plot that was fertilized in the study. Suppose an additional plot type in which 100 kilograms of fertilizer was applied to each plot had also been included in the study. The peppers grown in these plots were harvested 77 days after planting in the fields. The results are shown in the following table. Okay, based on the available information, how did the total capacinoid concentration of the peppers change? As the amount of fertilizer applied changed from 0 to 50 to 100. Okay, so based on the, okay, so when was it 0? Was it 0? Yeah, it was 0. We are looking at which one? Yeah, let's just stick to V1. Yeah, so let's just stick to V1 and let's look at 77 days. So I'm looking at L and N. So I'm looking at L and N for V1. Okay, so when it was 70 and then it was 78 when I applied fertilizer 50 grams, and then it became 91 when I applied 100 grams. So for each pepper variety, the total capacinoid concentration increased only, right? Let's just verify with V2 also. V2, 77 days, again LNN. So 92 to 105, and then it went up to 110. So it's option A. Okay. For each of the 3 pepper varieties, which plot was most likely intended to serve as the control for the effect of applied fertilizer on peppers that were harvested when they were red? When they were red. Okay, so that would be plot O, right? Because plot O did not have a fertilizer applied. So that's plot O. That's the control. Based on the description of the study, how many pepper plants were planted in each plot? Okay. So 80 to 200 plants were divided into 4 equal groups. So 50 plants per plot, right? So it's 50. Yeah. Okay, assume that the average mass of a dried V1 pepper was 20 grams. On average, the total mass in milligrams of capacinoids found in a V1 pepper from plot M was closest to which one of the following? So V1 from plot M. V1 from plot M, 60 milligrams per grams is the capacinoid concentration. It is 60 milligrams per gram. So 1 gram, so in 20 grams, it would be 1200, right? Option J. Because in 1 gram of chili pepper, you have 60 milligrams of capacinoid. So in 20 grams, you would have 1200. Okay, that was the science test. Let's quickly grade this. I have the answers with me here. The answer key for science is here. Okay. AHDHB, AHDHB, GDHAH, GDHAH, AFDGC, AFDGC, 16, GAJBJ, AJB. Okay, GA. So 17 is not correct. GA. Just confirm. Yeah, 17 is A. GAJB. J. 20 is J. 21 CGCFC. CGCFC. 26 GBGAJ. BGAJ, 31 BFCFA, BFCFA, and 36 GAJAJ, GAJAJ. Okay, so we got all correct except that one question, 17. Let's see what happened here. 17 is A. Yeah, it is A. Consider the mixture that resulted in the suspension with the lowest pH in study 2. Okay, so lowest pH in study 2 was mixture 1, right? According to the results, was the bulk density of this mixture greater than, so bulk density of this mixture 150 milligrams per milliliter. How is this A? Bulk density of this mixture is 104. It is less than, right? Am I missing something here? Lowest pH. Let's verify. Lowest pH is mixture 1, right? And that has a bulk density of 104. That's less than 150. I don't know if this is a mistake, but I still think the answer should be B. Let me see if yeah, I don't think there is any problem with the units. Okay, we'll check this. I'll check this and I'll come back to this question, but I don't think this is a mistake. Uh, let's see. Okay, fine. So this was the science section of the April 2021 Form D05. Hope this exercise was useful. I've already uploaded the solutions to the English and the math sections and to the first reading passage. I'll be working on the remaining reading passages soon. So come back and check out those solutions as well. I'll see you guys soon. Take care. Bye-bye.